Hey guys, welcome to my channel. My name is Aditya and today we will be discussing about the hello world of machine learning, which is iris flowers classification. So let's get started. Now I'll take you to my screen. This is the Jupyter notebook in which I have coded this iris flowers classification project. Looking at the first cell in which I have imported all the necessary libraries which will be required in this project, such as TensorFlow, Pandas, Seaborn, and Matplotlib. So without wasting much time, we will run this. So it ran efficiently. Now the second cell, which contains the column names and the species. In this iris flowers dataset, there are only three species. To make the dataset simpler, the names are Setosa, versicolor, and virginica, as you can see. We'll run this cell too. After running this cell, we have to import the training path and the testing path to load the train dataset and the test dataset. In order to do so, I have used this Keras library, which is given in TensorFlow. So if I run this, and now if I want to see a glimpse of how my dataset looks like, I will use the command train.head. So this is how my dataset looks like. It actually runs and displays the first 5 rows. So the first column is sepal length and all the way to species. So in order to see the glimpse of the tail of the my data set, I'll use train.tail. Now I can see this. So if I want to get some information regarding my data set, like I want to know the data type, the count, and such things, I'll use train.info. Here you can see the data type is given, the memory usage is given, everything. Now if I want to see some statistical means of my data, I'll use train.describe. So it calculates the count, mean, standard deviation, minimum, 25%, 50%, 75%, and maxima. So here you can see all the values. Now I want to plot some data analysis graph in order to see how my data looks like. So here I have used this dfcnt train.groupby. So what does groupby do? Groupby groups everything according to the same row or column. So I've used species as group by, so it will group by according to the species. There are total of 3 species, so it will group by a total of 3 species. So we'll run this, and this is the plot which I got. 0 was for Setosa, 1 was for versicolor, and 2 was for virginica. And these are the respective counts. This graph shows us the count of each of the species in the data set. As we can see, Setosa and virginica have the same count, whereas versicolor is slightly lesser in number. Next, I will group by in terms of species only, but I'll select all the 4 columns because I want the data of all these 4 columns, and then I'll select dot mean because I want the mean of all the sepal lengths, sepal widths, petal lengths, and petal widths. And then I have used this dot reset underscore index. What does this statement do is it will convert this statement into a data set so that we can use it easily in order to plot graphs. So we'll run this. It shows warning but nothing to worry about. Next, I have constructed this function flower attribute, and the parameter which it uses is attribute. and then I'll return this point plot. Let's run this, and now I've called this function. I've set the attribute as sepal width. If we want to change, we can change it into sepal length, let's say, and then I'll run this. So here I got an exciting plot where 0 was for setosa, 1 for versicolor, and 2 for virginica. So as the species vary, the sepal length also vary, the mean of sepal length. So the sepal length is highest for virginica and lowest for setosa. As you can see, we can predict various attributes using this by just changing the parameter value. Next, in order to train our data set, we'll pop the species. Since we have to predict the species of the flower using the 4 attributes, we should pop the species from here and store it in another data set. Now we'll again see if the species got popped or not. So yeah, the species were popped. Now there is no species column here. Now I'll define an input function. In order to take input from the data set, we should define an input function. So here I ran this cell. Now, for example, if we have certain columns which are numeric or categorical, in this data set we have all the numeric columns which contains all the numeric values. But if we have string columns also, like a sex column, male or female, we can use the property of categorical columns too. But since here we don't have any of the string columns, we will use only the numeric column attribute. So we'll run this. It shows that the numeric column is sepal length, whose shape is 1, and then the data type. For all the columns it will show like this. Now, in order to classify the model, I have used this DNN classifier, which expands to deep neural network classifier. It has a variant also which is known as linear classifier, but linear classifier can only be used when the dependent and independent variables vary linearly. Here in this case, this is not the case. So we are using DNN classifier instead of linear classifier. So we'll run this. It ran and we can see all the necessary output. Now we'll train the model. I have used the input function as input underscore function. I called the input function and training here is true since we want to train the model, and steps are 5000. Since more number of steps would mean more training here. So now I'll run this, and as you can see, the model is getting trained. Initially the loss was 1.94 and it's reducing step by step. So the loss here you can see 0.8, 0.7, 0.7. Okay, so it ran completely, I guess. Yeah. So the loss for final step was 0.67. Not a huge loss, but it's a significant loss, I can say. Now I'll print the accuracy using the evaluate function. We'll evaluate the accuracy of our model. So the accuracy of the test set was 0.567, which is pretty good, I must say. Not like it's average, not that much good. Now we'll run this another input function which we created just to ensure that the data set goes in the form of tensor rather than the dictionary. And the features we have used are again 4 of them. Now we'll predict what is the species type based on the following four parameters. You can set their values. I have already setted a few, so we can change them. Like I'll change it to 4. I'll change this to 3. Okay, now we'll run this, and this will predict the probability of a species. While running this, like for the following parameters, it predicted the species as Virginica with a probability of 57.5%. This is how we treat the iris flowers classification dataset.